All right, hello, Calculus 1. We were in 5.1, we learned antiderivatives, integration, a lot of good stuff in there to practice, but I'm moving into 5.2 and we switch gears, we do this area under a curve. And so I drew a picture here, I got a function here, 1/4 x squared plus 1, that's just a parabola. It's kind of a wide parabola. And so this is half of it here, sort of. I'm just working from 0 to 4, so I'm working from 0 to 4 under this parabola. We're going to find this area, and we're going to use 4 rectangles. So what you do is you take that whole width from 0 to 4, 4 minus 0, and you divide by 4 rectangles, so you get the width of each rectangle. We call that delta x. The width of each rectangle is 1. If you're going to divide this into 4 rectangles, the width of each rectangle is 1. That's kind of obvious, but there's a little formula for you. And then you look at this picture and you might say, what do you mean? I don't see any rectangles. Well, the width is 1. The height, to make it a rectangle, I need to top it off with a straight line. I need to make a little height. So this is an estimate of the area. Now, there's kind of 3 different kinds of rectangles we can do. Let's start with what we call an inscribed rectangle. An inscribed rectangle is inscribed under the curve. In this little subinterval from 0 to 1, I need to pick a height. I can either use this height, or maybe this height, or maybe some height in between, but I need to find the height of this rectangle. To make it an inscribed rectangle, you'd pick the lower y value here and you cross across there and you make that height. For the next rectangle, I'm going to pick this left end point and I'm going to find that height. You can tell I'm missing a lot of area. This is going to be an underestimate. For this third rectangle, I picked the inscribed rectangle. I picked this lower height and I go straight across and I call that my height of my rectangle. For the last rectangle, I picked the lower inscribed rectangle, and that's my height. So there's my 4 rectangles, and you can tell I'm missing a lot of area. But let's just get organized and try to find that area. So I kind of make a little chart here. I have delta x, which is the width of the rectangle. And there's 4 rectangles. What's the width of the first one? 1. What's the width of 1? 1. I made them all width 1. They could be width 2. They could be different widths, different problems. Then to get the height, I'm plugging in this little, we call it little mi. And for the first, the little I is just a little subscript that I'm going from 1 to 4. So the first rectangle is little m1. I plug it into the function to get the height. This is the y value, but the little mi is the x value. So if you remember, what did I plug in? I plugged in a 0 to get that first height. And when I plug 0 in the function, the height is 1. So there's the height. Height is the proper word. That's the height of that first rectangle. To get the next rectangle, I had to plug in that left endpoint. I plugged in a 1 to get that inscribed height. I plugged in a 1, that's the x value you plug into the function to get the y value. When you plug it in the function, you do the math, that's 1/4 plus 1, that's 5/4 or 1.25 if you don't mind. For the third rectangle, we plugged in a 2 to get the height of the rectangle. I plugged in a 2 to get the height of that inscribed rectangle. When I plug in a 2, the y value is 2. The y value is 2. That's the height. For the last rectangle, I plugged in a 3. I plugged in the left endpoint for the height of the inscribed rectangle. And when I plug in a 3, I get 9/4. That's 2 1/4 plus that 1. That's 3.25. I think I got a fairly accurate picture. That does look like about 3.25. Okay. Well, there you go. There's the width, there's the height. When you multiply width times height, you get area. So over here, I'm making a little chart for my area. 1 times 1 is 1. That's the area of the first rectangle. 1 times this is 1. That's the area of the next rectangle. That's a 2. 1 times this is 3.25. There's the areas of the 4 rectangles. I would like to add them up. You know, when we add things up, we use this summation symbol. I'm adding up these 4 rectangles. Anyway, the answer is, I think it's 7.5. That's the area using inscribed rectangles. All right, let's do it again. And by the way, you know, that's an underestimate. Let's use circumscribed rectangles. Circumscribed rectangles. This is kind of a little bit, it's easy, but it's a little bit of hard work. I'm making a little chart again. I'm going to have delta x, which is the width again. That's 1, 1, 1, 1. I'm doing 4. But this time I'm going to have different heights, because instead of the inscribed rectangles, for that first, I'm going to do an overestimate using the circumscribed rectangles, meaning in that first rectangle, I'm going to pick 1 to get the height of that first rectangle. That'll be an overestimate. For that second rectangle, I'm going to pick 2 to get that height. Oops, to get that rectangular height of that second rectangle. For the third rectangle, I'm going to pick 3 to get that height. And for the last rectangle, I'm picking the right endpoint, 4, to get the height of that rectangle. So these are, you can tell, that's way overestimate here. But here, now we use this capital MI. Those are the X values that you plug in to get the circumscribed rectangle. Anyway, for that first rectangle now, I'm plugging in the 1. Right. I'm plugging in the 1 to get that height. I had that a minute. When you plug in that 1, you get 1.25. When you plug in next rectangle, you plug in a 2. And you plug 2 into the function. Oh yeah, I got 2 when that happens. Next rectangle, I plug in a 3. I plug in a 3 to get that height of that third rectangle. That was 3.25. That's right, 3.25. For the last rectangle, I'm plugging in that right endpoint to get a 4 to get that height, which is 5, I think. 4 squared, 16 over 4. Yeah, it's 5. So I'm plugging in the 4, but I'm getting the height of 5. Cool, man. These are all my heights. I got my heights multiplied by my widths. That's what area is. The area is the heights multiplied by the widths. And here they are, 1.25, because the width is 1. 2, 3.25, and 5. I squished them up a little bit there. When I add these up, the answer is 11.5. That's the overestimate of the area. So, you have homework that makes you do that. Inscribed rectangles, circumscribed rectangles. You just have to pick the right endpoint to get the right height. Either you're getting an inscribed height or a circumscribed height. Now, the truth is, the best way to do this is, I'm going to erase this one, is I like to use what I call middle scribed rectangles. These are awesome. Let's do this real quick. Middle scribed rectangles. And there is a few problems in the book that say, let's do that. So here you go. I'm erasing my little pink heights here. Get rid of these heights. I'm going to redo this problem with middle scribed rectangles. So I'm still doing those 4 rectangles, but this time, instead of using the left endpoint or the right endpoint to give me that underestimate or overestimate, I'm going to pick this midpoint. And I'm plugging it in, and that's where I'm going to get my height of my rectangle. And what I'm going to get is a little overestimate and a little underestimate in the same problem. So here I go. Let's set this baby up. I'm setting up a little chart. My width, that's my delta x. That's easy. That's 1, 1, 1, 1. My height, this time I'm going to use little CI. These are my little middle numbers that I'm plugging in instead of little MIs and big MIs. Sorry, these are little, I'm going to call these CIs. And so this will be my height. And then when I find the heights, I'll multiply my heights and my widths. I'll get my areas, and then I'll add them together to get the estimate of this area. This will be a way better estimate. Remember, I had a lower estimate of 7.5. I had an upper estimate here of 11.5. That was my inscribed and circumscribed rectangles. Let's see what this does. So what am I doing for that first rectangle? I'm plugging in the midpoint. I'm plugging in a half, and I'm trying to get the height. When I plug in a half, that takes a little work. That's a 1/4, there's a 1/4, that's a 1/6, that's 1 1/16. Wow. 1 1/16. I might need a calculator. I think that's a 0625. 1.0625. For this next rectangle, I'm plugging in a 3/2 or a 1.5. I'm plugging in a 3/2. Look at this. I'm going to get this middle height. That's awesome because I get a little overestimate and a little underestimate. This is probably going to be good. For this one, I'm going to plug in 2.5. I'm going to get this middle height. For that last one, I'm going to plug in 3.5. And I'm going to get this middle height. Remember, these x values aren't the height. They're the numbers you plug in. I'm trying to get the height. So when I plug in that 3/2, I do a little math. 3/2 squared is 9/4. I get 9/16 plus that 1. 1.5625. For the next rectangle, I'm plugging in 2.5. I could call it a 2.5. That's what it is. I'm plugging in 2.5. I'm squaring it. I'm dividing by 4, and I'm adding 1. I'm going to just do that here. 2.5 squared. Divide by 4. Add 1. 2.5625. 2.5625. Finally, I'm plugging in a 3.5 for that last rectangle, and I'm going to get that height. 3.5 squared divided by 4 plus 1 is 4.0625. 4.0625. Those are my heights. When I multiply by the width of 1, of course, my area is that number. My area is that number. My area is that number. And my area is that number. I didn't round any of these off. I want to add these up. This is my middle sum, my middle scribed rectangles. This is awesome. I want to add those up. Here I go. Plus 2.1. I hope I didn't make any errors. You guys can double check me. Please double check me. Please double check me. Wow, I get 9.25. 9.25, which is, I don't know if that, I don't think that's right in the middle of that. I don't think it's, but it's somewhere in the middle. Right, that's a way better estimate of the area under this curve. Still an estimate though. It's still an estimate. Listen, I'm gonna spill the beans. In 5.2, you're adding up these rectangles. 3 different kinds: inscribed, circumscribed, middle scribed. So this was fun. This is a little bit complicated, a lot to look at here. But I'm going to end this with the climax. Here comes the climax. You're going to love this. Don't turn off this video too early. The way you get the exact area, it turns out, and I'm jumping up to 5.4 when I do this. I'm jumping from 5.3, I mean 5.4, is you integrate. You integrate this function, 1/4 x squared plus 1. What's different is now you're doing a definite integral. We did some indefinite integrals, but now we're going to go do a definite integral from 0 to 4. So I'm just going to show you how to do this. And this is not an estimate. This is the exact area. By the way, you could sort of think of that function there as the heights. The heights are the function. That dx is sort of the widths. There's more to explain. But anyway, here we go. I want to integrate. X cubed divided by 3, that's 1/12 x cubed plus x. With a definite integral, you have these bounds from 0 to 4 is how you talk. And then at the end of integrating, you evaluate from 0 to 4. And what that means is plug in the 4. You get 64, 4 cubed is 64/12 plus 4 minus, plug in the 0, which is 0 plus 0. And this is the answer, and this is the exact area, whatever 64/12 plus 4 is. Let's do a little reducing. That's 16/3 plus 4. 16/3 is 5 1/3. 5 1/3 plus 4. Yeah, this is 5 1/3 plus 4. The answer is 9 1/3. That's the exact area. And you get that by doing an integral. That's the exciting conclusion. The exact area, you do a definite integral. That's sort of what the rest of this chapter is about. 5-2 makes you add up some rectangles, makes you get used to this estimating idea. By the way, look how good that middle sum was. Pretty damn good. That middle sum was pretty good estimate. This is the exact area under the curve. Maybe I'll have to explain that a little better, how we got that. It's not really magic, but it's good. All right, thanks for listening.